to this lecture where I'm answering your questions. Someone has asked a question. He sent this question to me. Of course, I'm attaching the PDF. I think you can see. They're talking about a body attached to one end of a string and the other end is fixed to this string. And then we have a vertical force of 0.5 G acting on the body and a horizontal force of 21 Newton acting on the body. Now they say the mass of the body is 2 kilograms, which gives us the information that the weight should indeed be at 2g. Now we know the examiner has not said, but we know that if this is a string, the intention will be developed in the string. If this angle is theta, then this one also be theta. Actually, in this question, the examiner says that he wants us to go ahead to find the tension T and then to find the angle theta. So we are also going to solve this. So now I want us to begin with resultant force acting on the body. And now, of course, remember when the body stops at this moment, that means that the body is in equilibrium. And if it is in equilibrium, then the resultant force of the body is actually always equal to 0. And so that's why we find resultant force. So if I start with 0.5, that is going to be, it's a vertical force, positive. 0.5, no. So it's vertical, so horizontal is 0, then you have 0.5 G plus, this is a horizontal force, so you have 21, and vertical you have 0, plus, this is downwards, so horizontal is 0, it's minus 2G, and then finally I have the tension. Horizontal is negative, so that's tension, that's T sine of theta, and it's positive T cos of theta. Because it's in equilibrium, then it's equal to 0, 0. So we want the tension. That is why we are going to go ahead to solve both vertically and horizontally. So if I resolve horizontally, okay, let me put it here where it's clear. If I resolve horizontally, of course you have 0 plus 21, that is 21 plus 0, that's 21. So I have 21 minus T sine theta is equal to 0. This implies that T sine theta is equal to 21. And we can call this equation number 1. Then you still also go vertical. When you go vertical, what shall you discover? You find out that you have 0.5 G minus 2G plus T cos theta is equal to 0. Definitely 0.5 minus 2 is a minus 1.5. If it crosses, you obtain T cos theta is equal to 1.5 G. And this makes equation number 2. So what are we going to do at this level? At this point, we can divide. We can say equation 1 divided by equation 2. So you have T sine theta is equal to 21, then divide by T cos theta, and this side is by 1.5 of G. So you'll find that this becomes tan theta is becoming 21 out of 1.5 into our G, we are going to use G as 9.8. And so if you compute this in the calculator, you get theta as equal to 55.01 degrees. Remember, for angles, it's okay to use 2 decimal places or even 1, but I advise you take 2 decimal places. Okay? Yeah. And so now, having the angle theta, we can go ahead and find T using either this equation or this one. But if I choose equation 1, so from equation 1, you'll be able to see that we have T sine of 55.01 is equal to 21. And solving this, you get the tension as equal to 25.6338 newtons. This will become your tension. So make sure for this process that you write your answers to 4 decimal places. So if we see this in your exam, we shall give you marks here and here. Then we give you mark for this and here, so that you can get your 5 marks. Yes, once again, I thank you for watching. This is our solution, so feel free to ask whoever has a question. Go ahead and ask the question. I'll gladly help you with your question. Have a nice day. I sign out.